Section 6.6 is on transformations of quadratic functions. All right, so transformations is kind of an important concept. Not necessarily like we don't do a ton of it in Algebra 2, but you do a lot of it in pre-calc and so on. So it's an important concept to know. So transformations for quadratic functions, meaning parabolas. We're going to talk about parabolas going right and left, up and down, stretching, compressing, and so on. So number one says graph f of x equals x squared minus 4 by using a table. So the whole point of this section is to continue to graph quadratic functions, but not have to draw a table every single time, a t-table. Okay, so we're going to start it out with kind of reviewing that. So if I have x squared minus 4, and I have a t-table, let's plug in negative 2, negative 1, 0, 1, and 2. So when I plug in negative 2, I get 4, minus 4 is 0. When I plug in negative, what am I doing? Yeah, okay, when I plug in negative 1 squared is 1, minus 4 is negative 3. When I plug in 0, I get negative 4. When I plug in 1, I also get negative 3. And when I plug in 2, I get 0. So we have negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. So we have that graph. Okay. So the parent function for y equals, for parabolas is y equals x squared. And y equals x squared looks like this. And that's kind of an important function to know what it looks like. Can you guys tell me some points on y equals x squared?
0, 0.
Yeah, we have 0, 0. What happens when I get 1? 1, 1, 2, 4. Yep. So you guys should kind of know what that one looks like. Do you guys all know what that looks like?
Yeah.
If I plug in negative 1, I get 1, and so on. All right, so how is this one different than the parent function? What happened to it? Where did it move? Yeah, it moved down 4, right? So we went down 4. Rodrigo, pay attention. So, yeah, you did not have to use a table. Can you guys tell why it goes down 4? Because there's a minus 4 on the end. Not very hard. So the next one is a little bit trickier. Okay, so when we see x minus 2, what I would think is that it's going to look like the parent function, only it's going to go left 2, and it doesn't. Okay, this one will end up doing like the opposite of what you think it does. It does. It goes right 2. So let's see why. Okay, so let's think about it. So when I told you guys about graphing parabolas earlier, I always told you that in the middle, we should put the point that is like the vertex. What's going to make this thing that's being squared? What do I plug in to make it as small as possible? 2. Do you guys all see that? So if I put 2 in, that's how I get 0 out. And then I want to plug in things on the left and the right of that. So I'm going to plug in like 3 and 4. I'm going to plug in 1 and 0, and so on. So I have 3 minus 2, and I square it, so I get 1. 4 minus 2 squared is 4. 1 minus 2 is negative 1, but when I square, I get 1. And 0 minus 2 is negative 2, but when I square it, I get 4. So when we sketch this out, we have 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. And so it is. It's moved to the right, too, from that parent function. So it's kind of confusing why this happens. Basically, we're going to be concerned with what's happening to the input and what's happening to an output. So what's happening to the x value, what's happening to the y value. So on the first one, at the very end of our function, we had minus 4. So we found all the x squareds that we had before from the parent function, and then we just took all those x squared values and we subtracted 4. So all the y values got shifted down 4. But this other one kind of involves like undoing a process. Okay, so when I plug in 2, that's how I got the original vertex, right? That's how I got 0 out. Do you guys understand what I'm saying? So like here was 0, 0. How was this affected? We now have, in this t-table, we have 2, 0. Well, we had 1, 1 before. What do we have now? We have 3, 1. Do you guys see what I'm saying? So what happened to these x values then? They increased by 2. Does that make sense? So when you have a minus 2 in parentheses, you have to undo that minus 2 by increasing your x, making your x2 bigger. So that's why it moves to the right 2. Do you guys understand that? So when something is not being squared, so this was on the outside, it's not inside parentheses with the x, it's not being squared, it does what you think it does, it just goes down 4. But when something was inside with the x, this minus 2, right? That was inside with the x. It ends up doing like the opposite of what you would think. So instead of adding or subtracting 2 from all of your x's, we don't subtract 2 from x's. We add 2 to the x values. It moves to the right. Do you guys understand what I'm saying? So inside is opposite. We're going to keep that in mind. All right, so if you guys want to use colored pencils, you can use some colored pencils. I had them out somewhere. If you guys want some colored pencils. So we're going to draw some transformations on these. I don't know how good my colored pencils are, so let's see. You guys just pass that room. Just grab some. Don't like try to pick the perfect color. Yeah, don't spend 4 hours picking the perfect color, right? Joey's going to do that. All right, so the vertical translation, I think the vertical one is the easiest one. So the vertical translation is exactly what you think it does. So if you had y equals x squared, and instead I had x squared plus k, it's going to move up by k. So this is y equals x squared plus k. It moves up by k. But if I have y equals x squared minus k, what do you think happens? It goes down by k, exactly. Nothing else changes about this parabola. So all we do is the y values are adjusted. The y values are added. We add k, we subtract k. So if I had the point 2, 4, and my k value is 3, so if I had x squared plus 3, and originally I had 2, 4 on my parent function, my new point is going to be at 2, 7. I'm going to add 3 to the y value. All right, so the horizontal one is the one that's different. It's the opposite of what you think. So when you have x minus k squared, it moves it to the right k. So this is x minus, I shouldn't use k, I'm going to use h. X minus h squared. That moves right h. So it's kind of the opposite of what you would think. You would think that it would move left because it's a minus, right? So if I have y equals x plus h, all in parentheses and squared, that means I move to the left h. Okay, so when the x value changes, so inside with the x, it does the opposite of what you think. If the y value changes, you do exactly what you think it does. So if it says plus, you go up. If it says minus, you go down. Manish. I don't know. Turn on the light at least. Will that help if I turn off the light? Oh, no. That makes it worse. Maybe one on, one off. All right. So this one starts out pretty easy. So when it says x minus 2 squared plus 4, tell me what it does. What direction does it move? So we go right 2, up 4. So the right 2 comes from the one in there. The up 4 comes from that right there. And so if I was doing a rough sketch, I would just go to the right 2, up 4. That's going to be where my new vertex is. Otherwise, it looks exactly like the normal parent function. All right, so if I have x plus 2 minus 3, let's talk about the x plus 2. It's inside parentheses with the x. It does the opposite of what you think. So it's going to go left 2. And then what about the next one? Down 3. So its vertex is going to be left 2, down 1, 2, 3, but otherwise it looks just like the normal parabola. Okay, so it's kind of a rough sketch. So if you wanted exact points, some people are really particular. Like just think about your parent function. Like remember how you had 0, 0, and then you had 1, 1, 1, negative 1, 1, 2, 4. You could always go over 1, up 1 to get a new point, over 1, up 1 to get another point if you wanted to. I don't care. You can just do like a little rough sketch. All right. So do we understand the right, left, up, and down? Good on that? All right. So I said that it was always the normal parent function, meaning just an upwards parabola and so on. But sometimes it's not. Sometimes we have downwards parabolas, right? So we need to know how to graph those as well. So if I reflect across the y-axis, so this is the y-axis, it's not a big deal. If I had that point 2, 4, when I sketch the new point, and if I go over the y-axis, it's negative 2, 4. All right? And then I sketch it in. So it's exactly the same parabola, right? Do you guys understand that? So if I plug in a negative, I replace my x value with a negative x value, it's exactly the same thing. So what that looks like as a function is instead of x, I have a negative x, and I square it. This is really just y equals x squared, right? If I have a negative, like negative 4 times negative 4 is positive 16. Isn't that the same as 4 squared? Yeah, do you guys understand it? So when I reflect across the y-axis for a parabola, it's not really that exciting. For other shapes, yeah, it's kind of exciting. Not exciting, but woo. But these other ones. So reflecting over the x-axis, what does this do when I reflect over the x-axis? So if I had my point 2, 4 before, and I go over the x-axis, what is the new point? 2, negative 4. Yeah, 2, negative 4. Oops, not negative 2. 2, negative 4. So that one does do something. That's the one that makes the parabola upside down. Okay. And what that will look like as a function is it will say like y equals negative on the outside and then x squared. So do you guys see when we have a negative not in parentheses with the x, that must affect the y value then. Anything inside parentheses affects the input, the x value. Anything outside of parentheses affects the y value. All right, so stretches and compressions. This is the one that's kind of weird for my students. Okay, I want you to think of two things. I want you to think of an accordion. Do we know what an accordion looks like? Yeah, it's like the thing where you play the piano on the side. Clark, do you know what an accordion is? Have you ever seen this? Like you pull it out. An accordion. So as I pull an accordion out, it gets wider, right? So I would call that stretching it. When I push it in, I call it compression, right? All right, and I also want you to think about taffy. So have you ever seen like someone pull like even like gum and they pull it out really? It's gross. So let's say I have taffy and I'm pulling it this way. Okay, what happens when I pull it this way? It gets longer, right? But what also happens? It gets really skinny. So one thing that might be like a stretch, like this is a stretch, I'm stretching it, right? But what's happening to my shape? It's getting really skinny. Okay, that's what I want you to think about for these. So a horizontal stretch or compression, well, let's do the vertical one first. Actually, that's a little bit easier. So a vertical stretch or compression by a factor of b, it's affecting the y value. Okay, vertical y value, right? So if I stretch it out, that would look like y equals b times x squared. And what happens is any point that we had, like this point, 1, 1, if I multiply it by 2, let's say, if I had 2x squared, it goes up to 1, 2. So 1, 1 goes up to 2, 1 if y equals, I don't know why I wrote it that way, 1, 2, geez, long day. 1, 2 if y equals 2x squared. Do you guys see what I'm saying? It gets stretched up. So every single point, so 0, 0 is still at 0, 0. But 1, 1 gets stretched up to 1, 2. And then 2, 4, if I double the y value, it'd be 2, 8, right? Do you guys see how that's going to stretch it vertically? All right, so if we compress it, so if I'm compressing everything, then that's like the taffy where I'm smushing it down. If I smush it down, it gets fatter. That's what's happening here. So this 1, 1, if I had like 1/2 x squared, it would kind of flatten it out, and it'd be really wide. Ugh, my pen is not calibrated right. It's driving me nuts. So this is y equals 1 over b times x squared. So if you have b times x squared, we say that it's a vertical, let me write it in another color, a vertical stretch by b. And then if you have a 1 over b out front, like a 1/2, 1/3, 1/4, something like that, any number less than 1, so you could even have like 2/5 even. This is a vertical compression or shrink. So compression by 1 over b. Okay. So we're going to do some examples, so don't freak out right now. Okay, now the horizontal ones. Remember I said anytime something's affecting the x value, it does the opposite of what you think. So if you see something like y equals 1/2 in parentheses x squared, we are not having the x values. We are multiplying them by 2. What will that do to the accordion shape? So my parabola shape, what will happen to it if I multiply my x's by 2? It will not, because I'm going to multiply them by 2.
Well, if you're multiplying those y values,
I'm multiplying the x values by 2. So like 2, 4 would now go to 4, 4.
Oh, well, then in that case, it
Stretches it out like this, exactly. So if you see like something like this, like 1/2 x in parentheses squared, you actually take all of your x's and you multiply them by 2. So it's going to take your parabola and it's going to go whoop, like that.
Multiply it with the denominator?
If it's like 1/, yeah. It's always the reciprocal of whatever it is. So this would be something in the form 1/b times x. So this is a horizontal stretch. And we say by b, right? Because we multiply all of our x values by b. So what do we think the horizontal compression does? If I have my parabola, it's going to go in. Okay, so we're going to go in. And what will that look like? B times x in parentheses squared. So that's a horizontal compression by 1/b. So it's by the reciprocal. Okay, and that makes sense if you think about the opposite operations. So if I had, if I had 1/2, that means divide by 2, right? So instead I multiply by 2. If I had 2 times x, then I divide by 2. All right, ready for some of these? Okay, so it says make a guess as to what you think happens, and then graph using a graphing calculator to see if you're correct. So we're going to make a guess. So there are 2 transformations that happen here. One deals with the 1/4, one deals with the negative. So 1/4, is it in parentheses or no? No. So does it affect the x value or the y value? Y value. So if it's not in parentheses with that x, it affects the y. So what do I do when I do 1/4 with y's? What does it do to it? Christian, you know?
I thought it was actually going to it'll increase the y value, also it'll be reversed.
The reverse is right, like reflection, but it doesn't increase the y values. It 1/4 the y values. It does exactly what you think. So if I do 1/4 of the y values, you take your parabola and it like shrinks it down, because all of these things, all of them are going to be 1/4 of where they were before. All right, so we're going to do a vertical compression by 1/4, and then we're going to do a reflection. It's affecting the y value. So if I have a point and the y value becomes opposite, which axis is it over? The x-axis, right? If the y value becomes the opposite, it goes over the x-axis. It basically becomes a downwards parabola, which we know, right? A negative x squared is a downwards parabola. All right, so I'm going to have you draw a couple steps in between. So let's talk about the parent function. So the parent function starts at 0, 0. We have 1, 1. We have 2, 4. We should know how to graph that. Does everybody know the parent function? Y equals x squared. So this is what y equals x squared looks like. So if I have a vertical compression by 4, my height was 0, it's still 0. My height was 2, 4, right, 4. Where does that height move now? If I do a 1/4, so if I had 2, 4 before, what happens to the y? It goes down to 2, 1. The ones that were at a height of 1 before, what do? They go down to 1/4. They're really tiny. Okay, so that's kind of our intermediate one. And then our last one, it just flips it over, right? So we have all the same points, they're just now negative. So that's the third graph. So that's our g of x. All right, so next one. So I have 2x in parentheses squared minus 5. 2x, what do we think? It's inside parentheses, so it affects the x value. It does the opposite of what you think. So instead of doing 2 times x, we have x is divided by 2, right? 1/2 times x. So if I'm having my x's, I'm doing a horizontal compression by 1/2. And then the -5, that's the one that everybody understands. -5, where does it go? Yeah, down 5. So we have our normal parent function. Sketch that one in first. We're going to do a horizontal compression by 1/2. So again, think about that point 2, 4. If I have my x values, where does it go? 1, 4, so it's here. Same with the other side. So that's kind of step 2. So sometimes if you label step 1, step 2. So then the last step, what's step 3? Down 5, that's it. 1, 2, 3, 4, 5. And you can take this point right here and you can go down 5. 1, 2, 3, 4, 5, and you get the other 2 there. So it's a really skinny parabola. Okay, do you guys get it? All right, so I don't have you do a ton of sketching because I know some of you guys are artistically challenged, but yes?
So I'm confused, why is it written as 2 times x, but we're really dividing it by 2?
Because it does you have to undo the operation. So that's a good question. So let me show you a picture. So if I had like y equals 3x squared. Okay, and I was comparing my t-tables between our parent function and this new function. If I wanted to get 1 out, let's say. So like see all these values we had before. If I want to get those same outputs, what do I have to do to the x in order to get a 1 for the y? What do you have to do? What do you plug in for x to get 1 out? 1/3. Do you see it? So that's why we're 1/30.
So x is the half value.
Yeah, anytime anything's inside with the x, you have to undo whatever operation is in there. It's kind of weird, isn't it? All right, so next up. So I have -5 times x plus 2 squared minus 6. The squared part's just telling you the shape is an x squared, a parabola. All right, so this one has 1, 2, 3, 4 transformations. Can we get the 4 transformations? I usually kind of go in the same order that I would go as if I was plugging a number in for x. So if I plug something in for x, I would first do that, then I'd square, then I'd do the 5, then I'd do the negative, then I'd do the -6. So we're going to do the 2, the 5, the negative, and then the -6. Okay, so let's talk about the 2 first. X plus 2. Yep, it moves left 2. The 5 out front. 5 times a bunch of stuff. And it's on the outside, so it affects which value? Y value. 5 times y. What's happening when I do 5 times the y values? Vertical. I heard someone say it. Stretch by 5. You're multiplying your y values by 5. All right, the minus out front. Down 5? No, not down 5. I was just writing it. I was like, yeah, you're right. A negative out front, what does it do to a graph, a negative? It's some kind of reflection, so we're going to do reflection over the x-axis. Oops. And then that -6 at the very end. Down 6. Do the rest of you guys see this, or Nick is the only one that gets this?
Wait, can you go over the third? Like, how did you figure out about reflection?
Because there's a negative out front. So the negative doesn't go with the 5. It's kind of like just out. It's another transformation. So whenever there's a -1 times something, it's some kind of reflection. All right, so the next one. This one has 3 transformations. We have the 3, we have the negative, we have the 2. All right, think about what those transformations are. Let's deal with the 3 first. Is it inside parentheses? Is it being squared? No. So what does it affect, the x or the y? It's changing the y. Okay, so if I have y's, it's exactly what you think. It says 3 times. What if I do 3 times my y values? What does that do? It stretches it, right? So it's going to be what we call a vertical stretch. By 3. All right, and then I have the negative out front. Well, what's a negative do? It's some kind of reflection. Where does it reflect? Yep, reflection over x-axis. And then the last thing, up 2, you got it. Okay, and you could check these. You could graph it on your graphing calculator. You would see it's exactly the same thing. Okay. Do we know how to use our calculators? Do I have to show you that? Okay. So it says sometimes these problems involve 2 horizontal transformations. Okay, so it's important that you factor out the reflection, stretch, compression before deciding how much the function has shifted left or right. So for instance, if you have f of x equals 3x minus 6 squared, it appears that it has a horizontal compression of 1/3 and it shifts right 6. So if I was trying to graph that, a lot of people say, oh, it's going to start over here at 6. Right, it actually doesn't. Okay, it actually starts right here at 2. That's where the vertex would be. So there's something strange going on. Okay, so if you see that you have like some kind of horizontal stretch or compression or a reflection with like a negative, and you also have right and left. So 2 things inside that parentheses. You guys see how there's 2 things, 2 transformations in there? The 3 and the negative 6. So if you have 2 things, you have to factor something out. So it could be written as 3 times x minus 2 squared which is really the same as if I square the 3. What do I do? So square the 3 and then leave this as x minus 2 squared. It could be written as 9 x minus 2 squared. So this horizontal compression of 1/3, you can write it as a horizontal compression of 1/3, but I could also write it as a vertical what? Stretch of 9. They're exactly the same thing. The numbers are just different, right? So think about it. If I have horizontal compression by 1/3, that means I'm bringing it in. Well, what happens with a stretch? It gets stretched out, right? They're both really skinny parabolas, right? So they're kind of the same, but the numbers are different. So a horizontal compression is the same as a vertical stretch, just they're not by the same like number. Okay, so it's kind of weird. All right, and then that shows you that it would just shift to the right too. So it says decide how the following function has been transformed from the parent function. So we can't say that it went right 8. A lot of people mess this up on like tests, on the final and so on. It doesn't move right 8, right? We need to think about where it goes, right 8. Yeah, we would need to figure out what happens. So we have the 4 that we pull out, and we have an x minus 2. All of that is squared plus 3. So I pulled out that GCF. So we did that because there were 2 transformations inside. Okay, now I go ahead and I square this 4. So if I square the 4, I get 16. And that's kind of the simplest form that you could have. So when I see it in that form, can you list the 3 transformations? So what about the 2? Right 2. What about the 16? Yep. Up 3. Yep. Exactly. All right.
So if it was a compression, would 16 be on the bottom?
It would be like 1/16, yeah.
Okay.
All right, so this next one. So same idea, we can pull out the 3. So we're going to have 3, and then what's inside parentheses? Yeah, x plus 1, right? So you guys see it's pulling on a GCF, basically. 3, so I have x plus 1. I'm going to go ahead and I'm going to square that 3, just because it's kind of messy looking right now. So I'm going to square the 3. So I'm going to say, oh, I have 1/27 times 9 times x plus 1 squared minus 7. And then I'm going to clean it up a little bit. I don't like having the 1/27 and the 9. So what could I write there? 1/3, yeah. So I'm going to say 1/3 x minus 1 squared minus 7. So tell me the, oh, dang. All right. I think I heard Natalie maybe. Was it Natalie? No? I heard someone at that table. Was it Abby? All right. I'm in the giving mood.
Me too.
All right. So we're going to go to the left 1 horizontal not horizontal. What am I doing? What else? Vertical what?
Bonus question.
Vertical, what did we say? Vertical stretch? Compression by 1/3. So that's where I say my students don't really like that, because what it does to the graph is normally if it was like that, it goes like a vertical compression. Whoops, it goes down. It gets flattened, right? And they're like, oh, but that looks like a stretch. Well, kind of. But the y's are smushed down, right? That's what's happening. So don't let that confuse you. All right, and then the -7, down 7. Exactly. All right, I'm going to let you guys go and break real quick.
You just call it flat.
Okay, so this next one, same idea. So we pull out, this time it has a reflection in there as well. So if I have a negative x, remember that's taking it and it's reflecting like over the y-axis, which usually isn't a big deal. For a parabola, if you just go over the y-axis, well, you get exactly the same thing, right? But when you have a right or left transformation, it actually is kind of important, okay? Because if you shifted it and then reflected over the y-axis, right, there's things involved there. So we have to, when we see we have a negative on the inside, we also have to pull out that common factor. So I'm going to pull out a -1, or just a negative, and when I do, I'm going to have x minus 4 in here, squared, -2. So I will admit, as a teacher, a lot of teachers mess this up, a lot of them. And I was one of them when I first started teaching. I totally messed this up, and I taught them in class, and then I had some students do the homework, and they were like, hey, I checked my answers in the back of the book, and it should be this, right? It should start like left 4, but it really says right 4. I don't understand. And it was because of things like this where there's that negative involved as well. So negatives you have to pull out as well. So if I have a negative and I square it, right, it actually becomes a positive. So it becomes 1/2, and then I have x minus 4 squared minus 2, like that. So that negative really, it didn't really do much, but it did do something because it changed that positive 4 into a negative 4, right? So it actually starts over here, right 4, and then it starts down 2 as well. And then it's like a 1/2, so it's kind of a flatter one. So that's the shape for that one. All right, so we're going to do a right 4. The 1/2 means there's a vertical compression by 1/2, and we go down 2. That's okay. All right, so the next one, if I was quickly doing this, I would pull out that -1/4, and this is where people, you know, if you're scared of fractions, fraction phobia, they're not fans of this. So think about what number you would need inside, so when I multiply a -1/4 in, I would get +2. In other words, what you're saying is 2 divided by that -1/4 gives me -8, right? That's what goes in there. And you guys can check, if you multiply it back in, don't you get a +2? Sure. All right, so then we're going to square that -1/4, so I get a negative on the outside. I still have my 1/16 from here and here, and then I have x minus 8 squared. So this involves 3 transformations, so I go right 8. What's the 1/16 do?
Horizontal compression.
Oh, so close, but not horizontal.
Why is it -8?
A vertical, yeah, pull up -1/4. Vertical compression. I would also accept, if you didn't say vertical compression by 1/16, I would also accept horizontal stretch by what number, though? By 4. Yeah, which is kind of weird. All right, and then reflection over x-axis, because that negative out front. Okay? Yeah, Manish? If it's inside parentheses, it's affecting the x value. So when you see a -8, normally you would think, oh, -8 with the x's, left 8. It actually does the opposite. You have to undo that. It goes to the right. So anytime something inside parentheses with the x, it does the opposite of what it says. So if it says minus, add 8. If it says times, divide, right? All right, and the last little thing we have involves completing the square, your fave. So this is called vertex form of a quadratic function. So we were kind of getting those into what we call vertex form. We can tell where the vertex is for all of those last problems that I just did. Can you guys tell where the vertex is? So like this one right here. it's left 1, down 7, the vertex would be at -1, -7. Does it make sense? So vertex form, it says when you are in the form y equals a times x minus h squared plus k, it has been shifted right h units and up k units. So your vertex would be over h up k. It'd be at h comma k. And then what the A out front is telling you is it's telling you like how skinny or fat it is and if it's upwards or downwards. So really the main thing we're concerned about is whether it's upwards or downwards. So if A is positive, it's upwards. If A is negative, it's downwards, right? Which we're used to. So you can write any quadratic equation in vertex form by completing the square. So first, make sure you pull out the coefficient in front of the terms that have x. In front of the terms, that should be front. So it says complete the square in order to write the functions in vertex form. So I'm only worrying about this part right here. So this plus 4, I'm just going to put it way over here on the end. I want to find that number that goes right here. Remember the magical number that goes right there? I want to find that. So I'm going to complete the square. So I do b divided by 2 squared. So if I take my 2 and I divide by 2 and I square it, what do we get? 1. I'm going to add that to this side of the equation. Now we've talked about this before. If I add it to one side, I have to add it to the other side. What I'm actually going to do is I'm going to subtract it over here as well. Because a lot of times we don't have y, we have f of x. And it's weird to have like f of x minus 1. It's always like f of x all the way through the problem. So does that make sense? I added and subtracted from one side. This is where people are always like, well, why would you do that? Because now when you simplify, you get the same thing. Like we did it for a reason, right? We did it for this. Okay. So we did it for the x squared plus 2x plus 1 because that's now a perfect square. So how does that factor? Yeah, x plus 1 times x plus 1, right? In other words, x plus 1 squared. And then what's on the end? Plus 3. This is now in vertex form. When it's in that form, we can tell what our vertex is. -1, 3. That's it. Found the vertex easily. Yeah?
I understand why subtraction would be. Actually, I'm not sure. Why exactly does adding something to the parentheses cause it to decrease?
Adding, like, are you talking about the transformations? Are you going back to those?
Well, no, I mean, I'm just trying to.
You can do a t-table, but you will see that it starts on the left. Yeah. So if you do a t-table, you'll see it starts there. But I would play around with it and do some examples. Like if you have x minus 2 squared at the beginning, we did something like that. Right, and we saw that it moved to the right too. Yeah, so anytime anything's inside with the x, it does the opposite because you have to undo an operation to get the same outputs, the same y values. All right, so this is where it gets a little bit harder. So these are the ones that students have a really hard time with on the test. So if you have -2 x squared minus 4x plus 2, we're only worrying about the x's. So I said go ahead and like write that plus 2 way over there. We're not going to worry about it. And then I want you to pull out. Remember, you have to have a 1x squared in order to complete the square. So pull out this -2 from both of these. So when you pull out a -2 from both the x terms, you have an x squared plus 2x. Okay? And we're going to add some number in right there. All right, so what number am I adding? 1. Do you guys see why it's 1? Everybody? So we're all giggling. It's making me nervous. So we add a 1. So I also need to subtract something over here, right? We talked about that, add and subtract. But I didn't really add 1 on this side. Do you see how I added -2 times 1? Which is -2? Right? Because I'm adjusting this whole side of the equation. I put a 1 here, but it affected my equation by really adding a -2. Do you all see that? Okay, so how do I undo that operation then? I subtract a -2, so I'm going to add a 2. Okay? So sometimes, like, in previous classes, what I've done is I've done minus, and then I put the 1 there, but I do like a little house, and I put the coefficient that was out front. So do you guys see this coefficient right here? I put that inside the house. So -2. So then people are like, okay, I'm really subtracting a -2, right? You multiply these together. You can do the house thing if you want. Someone in my calc class was saying that the other day. Oh, I remember that house thing you used to do. All right, if you want to, you can do that. All right, so this becomes -2, and then I have x plus 1 times x plus 1, so x plus 1 squared, and then plus 4. That's now in vertex form. Can you tell what the vertex is? Where does it shift right and up and down and left and so on? Where do we go? We go left 1, up 4. So it's -1, comma 4. Done. All right, I'm going to show you how to cheat your way out of this question if it's ever on a test, which sometimes it is on things like the SAT. They ask, what's the vertex of this function, right? How do you cheat your way out? Do you guys know how to find the vertex of, you guys know how to find this without completing the square. We've already found the vertex. We do -b/2a, right? Couldn't we do that? Couldn't we find -b/2a? Sure. -b/2a. So we get -4 over 2 times -2. So we get 4 over -4, which is -1. And then we plug in that -1. Oops, getting a little messy there. If you plug in -1 squared minus 4 times -1 plus 2, we get -2 plus 4 plus 2. What did I say? Hang on, -2. What did I do here? So I get +4, right? Yeah. Isn't that the vertex? Yeah. So that means as long as you know the formula, as long as you know this y equals a times x minus h squared plus k, and you're like, oh, I know h, it was -1, so minus a -1 plus 1. And I know k, it was 4. What is a? Look back to your original. What do you think a is? -2. It's just like a, b, and c in the quadratic formula. A is always a, no matter what. So a is -2, and we just put that there. Wasn't that much faster? If you do that on your test or quiz, I'm fine with that. Like, you can do that. Does that make sense? Like, don't complete the square if you don't have to. So it's much easier to do that way. All right. We'll stop there.